Good evening, and welcome back to this quiet space we keep for one another, the place where we set down the weight of the day and let curiosity carry us somewhere slow and far away. There is nothing you need to do here tonight, no question you must answer, no thread you must hold on to. You can let my voice become a kind of soft current beneath you, and if your mind drifts away from the words and into sleep, that is exactly as it should be. That is the whole purpose of our time together. Tonight we are going to travel a very long way, though we will never leave the comfort of wherever you happen to be resting. We are going to lean our attention toward a single point of faint light in the night sky, a smudge so dim that most people who have ever lived walked beneath it without once noticing it was there. And yet that little blur, that soft gray breath against the darkness, is one of the largest single things a human being can perceive with no help at all. It is a galaxy. It is called Andromeda, and it is our nearest great neighbor among the islands of stars. We are going to spend a long and unhurried while tonight simply wondering about it, turning it over gently in the mind, the way you might turn a smooth stone in your hand before setting it down to rest. Take a moment first, if you would like, to settle. Notice the surface that holds you, the pillow or the cushion or the gentle give of the mattress beneath your shoulders. Let your breathing find its own slower rhythm without forcing it. And then, somewhere behind your closed eyes, imagine a sky. Not the sky of a city, washed pale orange by streetlights and humming with the noise of the day, but a deep and patient sky. The kind that opens above quiet fields or sleeping coastlines, or the high cold air of a mountain far from any town. The stars there are not the handful we are used to. They spill across the dark in their thousands, layered and uncountable, and among them, low and modest, there hangs a small oval of light that does not twinkle the way the stars do. It simply glows, steady and dim and ancient. That is where we begin, with that faint patch and with a single simple question that will quietly unfold into many others as the night goes on. How large is Andromeda really? And what does it even mean to ask such a thing about an object that exists at a scale our minds were never built to hold? It helps, I think, to start with the strangeness of seeing it at all. For most of the galaxies that fill the universe, we have no hope of glimpsing them without instruments. Their light is simply too thin by the time it reaches us, scattered across distances so enormous that it sinks below the threshold of human sight. They wait in the dark, real and immense and entirely invisible to the unaided eye. Andromeda is one of the rare exceptions. It is close enough and bright enough in its gathered whole that a person standing under a genuinely dark sky can look up and catch it. No telescope, no special knowledge. Only patience and a little darkness, and the willingness to let the eyes adjust until the faintest things begin to appear. There is something tender in that fact when you sit with it. For nearly the whole of human history, people have lived in close company with the night sky. It was not a backdrop they ignored, the way so many of us do now. It was a presence, a companion, a calendar and a compass and a storybook all at once. Those who tended fields learned to read the turning of the seasons in the slow procession of the constellations. Those who sailed the open water steered by the fixed points overhead. And those who simply lay back and looked found shapes in the scattered stars, and gave them names, and wove them into the long, quiet tales that were passed from one generation to the next around fires that have long since gone cold. Somewhere woven into that vast inheritance was this little glow, not understood as a galaxy, of course, for that idea would not exist for thousands of years, but seen nonetheless, noticed. A faint and curious thing that did not behave the way the stars behaved, that refused to sharpen into a single point, that hung in its corner of the sky as a soft and unexplained blur. If you ever wish to find it for yourself, on some clear night far from the glow of human lights, the path to it is gentle. You begin by finding the great square of the constellation Pegasus, a wide and patient pattern of 4 stars that mark out a rough box against the dark. From one corner of that square, a faint chain of stars stretches away, and these belong to the figure the ancient Greeks imagined as Andromeda, a princess from their old stories, bound to a rock at the edge of the sea to await her rescue. Just off to one side of that chain, in the empty seeming dark between the stars, the soft oval waits. To the bare eye, it is the faintest of presences, easy to lose if you stare straight at it. In fact, the surest way to see it is not to look directly at all, but to let your gaze rest slightly to the side, where the eye is more sensitive to dim light. Stargazers have used this small trick for longer than anyone can say. It is called averted vision, this gentle sidelong way of seeing, and it is strangely fitting that the largest thing you can see with your own eyes is best caught by looking a little away from it. And when you do finally hold it in your sight, the experience is quiet. There are no fireworks, no rush of revelation. It remains a blur, a soft patch of gray against the black. But knowing what it is transforms everything. You are not looking at a single dim object. You are looking at the gathered glow of hundreds of billions of stars, blended together across an unimaginable gulf into a single faint shimmer. Each one of those stars is a sun in its own right, many of them with their own circling worlds, their own slow histories. And all that vastness, arrives to you as nothing more than a tender smudge of light, no brighter than a faint star nearby. That contradiction, the immense reality and the humble appearance, sits at the very heart of what makes Andromeda so quietly astonishing. To begin to understand its size, we have to first say plainly what a galaxy even is, because the word slips off the tongue so easily that we forget how staggering a thing it names. We use it casually, as though a galaxy were simply another category of object, like a planet or a comet or a moon. But a galaxy is not a larger version of any of those things. It is a structure of an entirely different order. When we say galaxy, we mean a vast gathering of stars, often hundreds of billions of them, bound together by gravity and turning slowly through space across spans of time, so long they make the age of mountains seem brief. And it is not only stars. Threaded through and around them are great clouds of gas, lanes and curtains of fine dust, the invisible scaffolding of dark matter whose presence we feel but cannot see. And somewhere near the center, very often, a region where gravity gathers into something so dense that not even light can climb free of it. Andromeda holds all of this and more. It is not simply big in the way one object is bigger than another. It is big in the sense of containing multitudes, of holding within itself more suns than a person could count in 1,000 lifetimes. So when we ask how big it is, we have to be honest that the question has many meanings at once. Are we asking the width of it, the distance from the tip of one spiral arm to the tip of the other? Are we asking how many stars are folded into it, each with its possible planets and its possible quiet dramas? Are we asking after the invisible weight of the dark matter that wraps around it like a deep and silent ocean, shaping the way it pulls on everything nearby? Or are we asking something gentler and more human, asking what it means to us, to be the closest great spiral galaxy to our own? A neighbor near enough that our two fates are already gently tangled together by the slow hands of gravity. For Andromeda, the word big is never only about kilometers or light years. It is about perspective. It is about stretching the soft clay of human imagination into shapes that very nearly refuse to be made. Think for a moment of the largest thing you can easily picture. Perhaps a mountain range, ridge after ridge fading blue into the distance. Perhaps the open ocean seen from a high cliff, stretching unbroken to a horizon that curves away from you. Perhaps the whole round face of the Earth as it appears from the edge of space, blue and white, and impossibly delicate against the black. Andromeda is larger than all of these by margins that have no real meaning in everyday speech. It does not fit inside any comparison we can comfortably hold. And yet it began this night as nothing more than a faint patch you might miss entirely. That is the journey we are on. From the smudge to the immensity, slowly, with no need to arrive anywhere in particular, only to wander. Let me give you the central number now. Gently, the way you might set a candle on a table rather than light a fire. The light you can catch from Andromeda with your own eyes has been traveling toward you for roughly 2.5 million years. 2.5 million years. The light entered the dark on its long journey when our distant ancestors were still shaping the first crude tools from stone, long before any city, long before writing, long before there was anyone who could have wondered what a galaxy might be. It crossed a gulf of about 2.5 million light years to reach you, and a single light year is the distance light travels in 1 year, nearly 10 trillion kilometers, a number that already slides past the mind without quite catching hold. Multiply that almost unthinkable distance by 2.5 million, and you begin, just barely, to sense the size of the emptiness that separates us from our nearest large neighbor. And here is the part that quietly rearranges everything. That gulf, vast as it is small. It is one of the shortest distances in the whole catalog of intergalactic separations. Andromeda is close. It belongs, along with our own Milky Way, to a modest gathering of galaxies that astronomers call the local group, a small neighborhood in the unimaginable city of the cosmos. Most other galaxies lie tens or hundreds of millions of light years away, their light so old that it left them before humanity existed in any form. Andromeda, by contrast, is near enough to be seen, near enough to be studied in detail, near enough that we are slowly drifting toward one another across the dark. Its nearness is exactly what makes it so precious to us, and at the same time it is a humbling reminder of just how staggeringly large the universe truly is, that this, our close companion, our next-door neighbor, should still lie 2.5 million years of light away. When you look at that faint smudge, what your eyes are actually gathering is only the brightest part, the crowded central hub where the stars are packed most densely together. Spread out around that core, far too faint for the naked eye to catch, are the great spiral arms, sweeping outward across hundreds of thousands of light years. They hold younger stars and pockets of glowing gas, where new stars are even now being born. And they are threaded with dark lanes of dust that ripple through the starlight like shadows moving underwater. If our eyes were built differently, if we could see into the infrared or the ultraviolet, Andromeda would appear far more intricate than the simple oval we perceive, with delicate tendrils of structure reaching outward far beyond anything we imagine when we say the plain word galaxy. But to us, in the quiet of the night, it remains a blur and a question. How big is it really? That is what we will unfold together slowly, with room left over for wonder. There is a particular feeling that people describe when they find Andromeda for the first time with their own eyes, and it is worth lingering on. Because it is the feeling this entire night is meant to gently evoke. They speak of two things arriving at once, humility and wonder braided together. The humility comes from realizing how small your own vision is against the scale of what you are seeing, how the eye can gather only the faintest hint of something so vast. And the wonder comes from the opposite direction, from realizing that despite that smallness, despite the limits of a single pair of human eyes, you are nonetheless connected, in this very moment, to something immense and ancient and entirely real. You do not need a spacecraft. You do not need an observatory perched on a far mountaintop. You do not need a single scientific degree. You need only darkness, a patch of clear sky, and a little patience. That accessibility is a quiet part of Andromeda's gift to us. Imagine it if you have never had the chance. Picture yourself somewhere far from the wash of artificial light, perhaps in a wide and silent field, or beside a still lake that mirrors the stars, or high on a slope where the air is thin and cold and clean. The sky above you is brighter than you have ever seen it, crowded with stars in numbers that almost feel like too much. The pale band of our own Milky Way cuts across it like a river of faint mist. And there, beside the chained figure of the Princess constellation, you notice something that is not quite a star. It looks almost like a fingerprint pressed lightly onto cold glass, oval and soft and easy to overlook. You stop. You let your eyes settle and adjust. And slowly the patch grows more certain, more present. That is Andromeda. That is another galaxy entirely. That is light that began its crossing of the dark long before any human being walked upright, arriving at last tonight to rest against your waiting eye. It is a different thing, this, from seeing a photograph. A photograph can show you the galaxy in extraordinary detail, its arms picked out in color, its dust lanes sharp, structures revealed that no human eye could ever catch on its own. But a photograph is something that has been gathered and processed and laid out on a glowing screen. Seeing Andromeda with your own eyes is not about detail at all. It is about connection. You are standing beneath the same patch of sky that ancient astronomers studied and recorded on parchment by candlelight. The same sky that travelers used to find their way across deserts and seas. The same sky that countless human beings have gazed into and wondered about, never knowing exactly what that faint blur might be. In that moment of looking, you quietly join a line of watchers that stretches back across thousands of years. An unbroken chain of curiosity, reaching all the way to the first person who ever paused and noticed and wondered. And the light does not arrive only once. This is a small thing, but I find it a beautiful one. Every single second, fresh photons stream across the gulf and fall upon the earth, upon rooftops and rivers and sleeping cities, upon the open eyes of anyone who happens to be looking up. The light you might have seen last night is already gone, absorbed and ended. The light you would see tonight is new, a fresh batch of travelers who began their journey just as long ago but are only now completing it. So meeting Andromeda is never truly a single event. It is an ongoing relationship, a steady and silent rain of ancient signals that has been falling on this world, without pause for far longer than there have been eyes to receive it, and will go on falling long after. Let us sit for a while with the idea of scale itself, because it is the doorway through which everything else tonight will pass. Our minds are exquisitely well suited to the scale of ordinary life. We understand the size of a room, the distance to the next town, the span of a human lifetime measured out in seasons and birthdays and slow, familiar changes. Even when we stretch ourselves, we manage only so far. We can hold the rise and fall of whole civilizations, kingdoms blooming and fading across centuries, and that already feels like reaching toward the edge of comprehension. But galaxies do not operate on any of these scales. They turn through spans of millions and billions of years. Their distances are measured in light years that climb into the hundreds of thousands. To glimpse that immensity, even for a single breath, is to recognize that the entire story of humanity is a thin, bright line drawn across a canvas, so vast that the line very nearly fails to register at all. And yet here we are, somewhere along that thin, bright line, noticing, reflecting, asking our quiet questions. There is something almost unbearably moving in that if you let yourself feel it. Consider our own home first, the galaxy in which we are gently spinning even now. The Milky Way holds something like 400 billion stars. Each one of those is its own enormous sphere of burning gas, pouring out light and warmth for billions of years at a stretch. Many of them are circled by planets, some rocky, some great and gaseous, some with moons of their own turning in the dark. The space between these stars is not truly empty either. It is filled with thin gas and fine dust, with radiation and magnetic fields, and the unseen presence of dark matter. All of that together, woven into a slowly turning disk, is what we mean by our galaxy. And here is the quiet, humbling part. As vast as the Milky Way is, it is not especially large. It is ordinary. Modest even compared to the giants of the cosmos, compared to Andromeda. The simplest way to begin measuring Andromeda is by its width, the diameter of its great glowing disk. And that disk spans something close to 220,000 light-years from edge to edge. Let me try to place that beside something we can almost feel. If you could somehow travel at the speed of light itself, the absolute fastest that anything can move through the universe, the speed at which those photons cross the gulf to reach your eye, it would still take you 220,000 years simply to pass from one side of Andromeda to the other. 220,000 years of travel at the speed of light just to cross a single galaxy. And remember, a single light year is already nearly 10 trillion kilometers. Multiply that by 220,000, and the numbers cease to behave like numbers at all. They blur into a kind of soft static, a sense of vastness that the mind can gesture toward but never quite grasp. And even that enormous figure describes only the part we can see. Surrounding the visible disk is a far larger halo of dark matter, reaching outward perhaps 1,000,000 light-years or more, shaping the galaxy's gravity and quietly holding the whole structure together. It can help to set this against something nearer home, something we have at least sent our machines toward. Our entire solar system, from the sun out to the distant edge where icy comets drift in the vast shell we call the Oort cloud, is roughly 2 light-years across. That is already a span so enormous that the spacecraft we launched decades ago, traveling faster than any object humans have ever built, are only now approaching its outer boundary. 2 light-years, and we can barely reach the edge of it within a human lifetime. Andromeda could hold that entire span across its width not once, not 10 times, but more than 100,000 times over. The difference in scale is so extreme that it feels almost unfair to measure both with the same words, the same light years. As though the language itself were strained past its limits by what we are asking it to carry. Another way to feel the size of it is to think not of distance but of number. As nearly as we can estimate, Andromeda contains close to 1 trillion stars. 1 trillion is 1,000 billion, a number so large it has almost no anchor in ordinary life. Let me try to give it one anyway. If you set out to count those stars, naming one every single second without ever pausing to sleep or rest or eat, you would need more than 30,000 years to reach the end. And by the time you finished, your count would already be wrong, because across those 30,000 years new stars would have been born and old ones would have died. And the galaxy would have quietly moved on without you. Each one of those stars is a sun. Many of them hold planets. The sheer number of possible worlds folded into this one galaxy is beyond any reckoning. And Andromeda is only one galaxy among hundreds of billions scattered through the observable universe. This is the place where the mind, reaching, tends to gently let go, and perhaps that letting go is exactly what we are here for. It can soothe the overwhelmed mind to anchor these numbers in something it can almost touch. So imagine the whole Earth shrunk down to a single grain of sand, held lightly between 2 fingers. Now imagine that every grain of sand on every beach in the world, all of them together, each represents one star. Even all the sand on all the shores of the entire planet, is not quite enough to capture the number of stars in Andromeda. And then, having stretched your imagination that far, remember once more that Andromeda is only one galaxy among unthinkable multitudes. What feels to us like the absolute summit of vastness is, in the context of the universe, entirely ordinary. Galaxies like this one are scattered everywhere, each one immense, each one holding its billions or trillions of suns, each one turning quietly in the dark. The immensity is not only in the size of any single structure. It is in the casual abundance of such structures, in the way the universe seems to produce them as easily as a meadow produces blades of grass. Astronomers, when they try to convey these scales to one another and to the rest of us, often reach for comparisons, because the raw numbers simply will not lodge in the mind. They might say that if our entire solar system were the size of a small coin held in your palm, then Andromeda would be the size of an entire continent. Or that if the Milky Way were shrunk to the width of a dinner plate resting on a table, Andromeda would be another dinner plate set nearby. And the whole observable universe would be roughly the size of the Earth itself, filled from end to end with countless plates, uncountable galaxies, layer upon layer fading into the dark. These pictures are gentle attempts to fold the immensity into something the mind can briefly hold. But however we frame it, the underlying truth remains the same. Galaxies are vast almost beyond meaning, and Andromeda in particular is vast enough that, when you catch its faint light, you are looking at something larger than language was ever built to describe. There is a quiet wonder in realizing how long it took our own species to understand what we were even looking at. For most of human history, this faint patch was not a galaxy at all in anyone's mind. It was simply a little cloud, a soft uncertainty in the sky. People assumed, when they thought about it at all, that it lay within our own Milky Way, just another wisp of luminous mist among the stars. The truth that it was an entire separate galaxy, a vast and independent island of stars adrift far beyond our own, did not arrive until well into the 20th century. And when it did arrive, it arrived like a sudden widening of every door at once. The universe, in a single stroke, became immeasurably larger than anyone had dared to imagine. We will return to that moment later, to the patient astronomer who first proved it, and to the long line of watchers who prepared the way. For now it is enough to feel the strangeness of it, that something so enormous could hide in plain sight for the whole of human history, mistaken for a small cloud, while it quietly held a trillion suns. The immensity of Andromeda is not only a matter of space, it is also a matter of time, and this is perhaps the gentlest and strangest part of all. The stars within it have been shining for billions of years. Whole generations of stars have lived and died inside that galaxy, each dying star seeding the surrounding clouds with the heavier elements forged in its core, so that the next generation might be born a little richer than the last. When you look at Andromeda, you are not seeing the present. You are seeing a single frozen moment from deep in its long story, a snapshot caught and carried across the dark for 2.5 million years. The scale is not only spatial but temporal. The galaxy's stars are older than the Earth itself, and they will go on shining long after our own sun has cooled into silence. To glimpse that is to feel, all at once, both very small and very deeply connected. Small because our lives are brief and our world is a moat against such backdrops. Connected because despite that smallness, we are made of precisely the same materials. The very same stardust forged in stellar hearts and scattered across space and gathered again into new stars and new worlds. The immensity of galaxies is not something separate from us. It is something we are quietly, intimately part of. Andromeda is vast beyond reckoning, and the atoms that compose it are the same kinds of atoms that compose the hand resting on your blanket, the same that compose your beating heart. Now, having let the size of the thing wash over us, let us turn the question slightly and ask something that ought to feel impossible. How could anyone ever measure such an object? How can we possibly know how far away it lies, how wide it stretches, how many stars it holds, How much hidden mass shapes its slow turning? These seem like questions that should lie forever beyond the reach of human senses. We are creatures bound to a single small world, with a single brief lifetime and a single pair of fragile eyes. And yet, patiently, over centuries, people built the methods to answer them. They learned to take something that seems wholly unreachable and to bring it gently into focus, into numbers and distances and shapes. It is one of the quiet triumphs of human curiosity, and it begins, as so much in astronomy does, with light. Light is the one messenger that can cross the gulf between the galaxies and arrive, at last, at our waiting instruments and eyes. Every photon that reaches us carries information folded within it, secrets about the star it came from, about the gas and dust it passed through on its long journey, about the speed and the distance of its source. By learning to read that light with great care, astronomers built an entire science of measurement out of nothing but the faint glow of distant things. It begins with something deceptively simple, with brightness. When you see a star or a galaxy shining in the dark, its brightness is really a blend of two separate things woven together. How much light it truly pours out, its real and intrinsic luminosity, and how far away it happens to be. The farther a source lies, the fainter it appears, fading with distance in a way that follows a precise and dependable rule. And this turns into a tool of astonishing power, for if you can somehow find objects whose true brightness you already know, then their apparent dimness becomes a direct measure of their distance. Such objects are sometimes called standard candles, and they are among the most beautiful ideas in all of science, a way of using the steadiness of certain stars as rulers laid across the dark. The most important of these, in the story of Andromeda, is a particular kind of star known as a Cepheid variable. These are remarkable stars that pulse, slowly swelling and shrinking, brightening and dimming in a steady rhythm that repeats over days or weeks. And here lies the gift. The length of that rhythm, the time it takes a Cepheid to brighten and fade and brighten again, is directly tied to how luminous the star truly is. A Cepheid that pulses slowly is genuinely brighter than one that pulses quickly, and the relationship is precise enough to trust. So an astronomer who patiently watches one of these stars, timing its slow breathing, can work out exactly how much light it really gives off. And then, by comparing that true brightness to how faint it appears in the eyepiece, the distance falls out of the arithmetic like a held breath finally released. This was the very method that revealed Andromeda's true nature. In the 1920s, an astronomer found Cepheid variables within that faint patch, measured the slow rhythm of their pulsing, and from it calculated a distance so enormous that there could be no doubt. Andromeda was not a cloud within our galaxy. It lay far, far beyond it. It was a galaxy of its own. That single measurement, made with patience and care, changed our understanding of the entire universe forever. Other tools have joined the Cepheid since then, each extending our reach a little further into the dark. Among the most powerful are supernovae, the brilliant explosions that mark the deaths of certain stars. One particular kind of these explosions detonates with a remarkably consistent brightness. So consistent that astronomers can use them as standard candles to gauge distances far greater than the pulsing Cepheids can reach. In Andromeda, such events have been seen and timed and measured, and each one helps refine our sense of how far the galaxy truly lies and how large it must be to appear as it does. There is something poignant in the thought that the violent death of a single star, flaring briefly bright enough to outshine its entire galaxy, becomes for us a quiet and precise milestone, a marker laid down in the dark by which we measure the vastness. Then there is the color of the light itself and what it tells us about motion. As an object moves away from us through space, the light it sends is gently stretched, its waves drawn out toward the red end of the spectrum, an effect we call redshift. As an object moves toward us, the opposite happens. The waves compress toward the blue. Most galaxies in the universe show a redshift, sliding away from us as the whole of space patiently expands. But Andromeda is one of the rare exceptions, and this is one of the most quietly thrilling facts about it. Its light is shifted not toward the red but toward the blue. Andromeda is not retreating. It is approaching. It is coming toward us, drawn across the gulf by the slow, insistent pull of gravity, moving in our direction at something like 110 kilometers every second. That blue shift is not only a measure of its motion tonight. It is the first whisper of a future meeting, a collision that lies billions of years ahead, when our two great galaxies will at last come together. But that is a story for much later in the night. Measuring the width of the galaxy joins two of these ideas together, the distance and the angle. From the Earth, Andromeda covers a certain span across the sky, an angular width that would stretch across several degrees if its faintest arms were bright enough for our eyes to follow. And once you know how far away it lies, that angle can be turned directly into a true physical size. In much the way that knowing how distant a mountain is lets you judge its real height from how large it looms against the sky. The farther the object, the larger it must truly be to appear that wide. Through this gentle calculation, astronomers arrive at that figure of roughly 220,000 light-years across. It is a simple piece of arithmetic in principle, but it leans entirely on having an accurate distance to begin with, which is exactly why the discovery of those pulsing Cepheid stars mattered so very much. Everything else rests upon it. Mass is the hardest thing of all to measure because it is the one quantity we cannot simply see. We see light, but we do not see weight. And so astronomers infer it from motion, in the same way you might judge the heft of something hidden by watching how hard it is to set in motion or to stop. The stars and the gas within a galaxy orbit around its center, and the speed of those orbits depends directly on how much mass is pulling inward through gravity. By measuring how fast the stars and the gas clouds in Andromeda are circling, astronomers can calculate how much mass must be present to hold them on their paths. And here they found something strange and wonderful and a little unsettling. The visible stars and gas, all the matter we can actually see, account for only a small fraction of the mass that must be there. The rest is unseen. The outer stars of Andromeda orbit far faster than they should, if only the visible matter were pulling on them. Faster than makes any sense unless something invisible and enormous surrounds the whole galaxy. This is where dark matter quietly enters the story, a vast halo of unseen mass cradling the galaxy, outweighing all its glowing stars many times over, betraying its presence only through the gentle insistence of its gravity. We cannot see it. We may not yet truly understand what it is, but we can feel it, written in the speeds of the turning stars. With every passing decade, these measurements have grown sharper, as our instruments have improved. Telescopes on high mountaintops and telescopes lifted above the atmosphere into space have learned to resolve individual stars within Andromeda, to track their slow motions, to catch the faintest flickers in their brightness. And yet, for all that precision, a measure of uncertainty always remains, and there is something honest and even comforting in that. Measuring a galaxy is always, in the end, an act of careful estimation, of models tested patiently against the evidence. Andromeda may turn out to be a little larger or a little smaller than our current numbers suggest. Its mass may be heavier or lighter depending on how the hidden dark matter behaves. The work is never quite finished. It is ongoing, generation after generation, each one adding a little more clarity, never reaching a final and absolute end. And this, too, is part of the wonder. The galaxy keeps some of its secrets. It does not surrender entirely to us, no matter how cleverly we look. It is worth pausing, as we drift here among these measurements, to feel how deeply human the whole endeavor has been. No one woke one morning suddenly able to weigh a galaxy. The ability was built slowly, piece by patient piece, across many centuries and many lifetimes, each generation handing its hard-won tools to the next. Ancient watchers noticed the faint blur and gave it a place in their maps. Medieval scholars cataloged it carefully, copying its position by hand. Early modern astronomers turned their first crude telescopes toward it and argued about what it might be. Then came the pulsing Cepheids, and distances could be known. Then came the splitting of light into its colors, and motions could be tracked. Then came the great telescopes, and individual stars could be drawn out from the blur one by one. Each advance was small on its own, incremental, almost humble. But together, laid end to end across the generations, they transformed Andromeda from an unsolved mystery into a measured and understood object. And still, the wonder does not fade. To say that Andromeda lies 2.5 million light-years away is to state a simple fact. To truly grasp what that means is another matter entirely, one that may lie permanently beyond us. To say it holds 1 trillion stars is to state a number. To genuinely imagine 1 trillion suns, each one blazing, each one with its own light and warmth and possible worlds, is something the mind can only gesture toward before gently giving up. The science gives us the numbers, but the awe is ours alone, and the awe does not diminish with understanding. If anything, it deepens, because now we do not only sense that Andromeda is vast. We know in careful detail just how vast it truly is. Let us drift now away from the galaxy alone and consider the company it keeps, because no galaxy of that size is ever truly solitary. It is tempting to picture Andromeda floating by itself in an endless dark, a single grand spiral adrift in the cosmic ocean. But galaxies are social things, in their slow gravitational way. They gather into families, bound together across millions of light years, moving in long, patient relationship to one another. Andromeda, vast as it is no lone traveler. It belongs to a community of galaxies that astronomers call the local group, and within that family, it holds a place of quiet prominence, the heaviest and most influential member of all. The local group is, in the grand scheme of things, a modest gathering. It contains more than 50 galaxies, though only a handful of them are large. The great majority are small companions, dwarf galaxies that cluster around the bigger ones the way small cottages might gather in the shelter of a few grand houses. At the heart of the group sit 2 spiral galaxies of comparable importance, 2 anchors around which everything else arranges itself. One is our own Milky Way, the other is Andromeda. Between them, these 2 giants dominate the gravitational landscape of the whole group, their great masses shaping the slow motions of every smaller member. There is a third significant galaxy as well, the spiral called Triangulum, smaller than the other 2 but still substantial, and it lies near Andromeda, perhaps even bound to it as a kind of large companion. Together these 3 form the backbone of the local group, with Andromeda the largest of them all. It can help to picture the whole arrangement as a kind of quiet valley town spread out beneath the night. Most of the dwellings are small, scattered cottages and cabins tucked here and there across the slopes, easy to overlook. But among them stand a few great houses, broad and imposing, that draw the eye at once. Those great houses are Andromeda and the Milky Way, the gravitational giants whose presence sets the tone for the entire neighborhood. The smaller dwarf galaxies gather close around them, circling like families living in the long shadow of their larger neighbors. Some of these small ones orbit the Milky Way, including the soft, cloudy patches visible from the southern hemisphere that early voyagers used to navigate. Others orbit Andromeda, 2 compact elliptical companions among them, sitting close beside the great spiral like attendants walking alongside a much larger figure. When astronomers map the local group carefully, they find Andromeda lying some 2.5 million light-years from us on one side of the gathering, while the Milky Way sits on the other. Between them stretches a vast emptiness, and yet their mutual pull is strong enough that, slowly, patiently, they are drawing toward one another. The whole local group spans roughly 10 million light-years from end to end, which sounds enormous and is. But set beside the truly great clusters of galaxies that lie further out in the universe, gatherings of hundreds or thousands of galaxies bound together, the local group is small. It is a quiet suburb, a modest corner in the vast and crowded city of the cosmos. Andromeda's role within this group is not merely to be a member. It is to be the heaviest of them, the one whose gravity reaches furthest and pulls hardest. Its total mass, counting the unseen dark matter, may exceed that of the Milky Way by some margin. Though the measurements continue to be refined, and the two may be more evenly matched than once believed. Whatever the precise figure, Andromeda commands a strong gravitational presence, shaping the motions of its many satellites and influencing the slow choreography of the entire group. When astronomers build their careful simulations of how the local group moves through time, they see Andromeda and the Milky Way drawn steadily, unstoppably toward one another, destined to meet and merge in something like 4 billion years. That future meeting will transform the group entirely, blending the two great giants into a single larger galaxy and rewriting the gravitational map of our whole cosmic neighborhood. There is something quietly comforting, I find, in knowing that we live within such a structure, that our galaxy is not alone but held in a family. The local group is not special in this. All across the universe, galaxies gather into groups and clusters, woven together by gravity into long filaments and vast webs that form the largest structures the cosmos contains. We simply happen to live in this particular group, with Andromeda as our nearest great companion. That nearness makes it feel almost familiar, almost approachable, despite its overwhelming size. To know that we belong to a group, that our galaxy is connected rather than isolated, gives a certain sense of belonging that reaches all the way up to the cosmic scale. We are not adrift. We are part of a gathering, a quiet community of galaxies turning slowly together through the dark. And Andromeda is the great neighbor whose light we can catch on a clear night with nothing but our eyes. Among the smaller members of this gathering, the dwarf galaxies, there is a whole subtle world worth resting on for a moment. Many of them are so faint and diffuse that they were discovered only in recent decades, revealed by patient deep surveys with powerful instruments. Their presence betrayed only by faint overdensities of stars against the background dark. They are interesting in their own quiet right. Some hold only a few million stars, a mere drop against the trillion in Andromeda. Some are irregular and shapeless, more like soft smudges of scattered light than structured galaxies. Others are smooth and featureless ellipticals, gentle ovals of older stars. Many of them orbit close to the giants, their stars tugged and stretched and slowly drawn away by the larger galaxy's gravity. These small companions remind us that galaxies come in every scale, and that the local group is defined not only by its giants, but by the long, quiet interplay between the small and the large. The way the great houses and the little cottages together make a town. Since we have spoken so much of our own Milky Way as a point of comparison, let us hold the two galaxies side by side for a while and notice how they are alike and how they quietly differ. It is a natural thing to treat the Milky Way as the standard against which all other galaxies should be measured, simply because it is the one we live inside. The framework that has shaped our view of the heavens for as long as there have been people to look. But when we set it beside Andromeda, our nearest great neighbor, The comparison becomes both fascinating and humbling. The two are kindred in many ways, and yet in their details they diverge. And those differences teach us not only what each galaxy is like, but what galaxies in general are capable of becoming. Our Milky Way is what astronomers call a barred spiral. At its center lies a dense bulge of stars, and across that bulge runs a long bar-shaped concentration of stars, from the ends of which the spiral arms unwind and sweep outward into the dark. Andromeda is also a spiral, but it seems to lack so prominent a central bar, at least not in the clear way ours possesses one. Its arms are broader and more diffuse, its central bulge larger and more pronounced, giving it a somewhat different character, a different bearing. Both galaxies are rich with stars and gas and dust. Both are attended by their circling companions. Both are cradled within great halos of dark matter that reach far beyond the visible light. But in the matter of raw size, Andromeda holds the advantage. Where the Milky Way measures perhaps 100 to 120,000 light-years across, Andromeda stretches to roughly 220,000. Set the two side by side and Andromeda would appear nearly twice as wide, its disk broader, its arms reaching farther into space. In the number of stars, Andromeda again pulls ahead. Our Milky Way is thought to hold something like 400 billion stars, an overwhelming number in itself. Andromeda may hold close to 1 trillion, more than twice as many, a more crowded and populous gathering of suns. In the matter of total mass, things grow trickier because so much of a galaxy's mass lies in the dark matter we cannot see, and measuring it is difficult and uncertain. Some studies suggest Andromeda is clearly the heavier of the two. Others suggest the two are more evenly matched than was once assumed. This uncertainty is simply the honest condition of studying galaxies. Their glowing stars are only the surface of them. Their true weight lies hidden in the invisible scaffolding around them, and we read that weight only indirectly, through the speeds of the turning stars. Yet the Milky Way is far from being merely a smaller copy of its neighbor. Our galaxy has its own strengths, its own character. The bar at its center shapes the flow of stars and gas, guiding material inward toward the core and influencing where new stars are born. And though Andromeda holds more stars in total, our Milky Way is thought to be forming new stars at a faster rate, kindling fresh suns more actively, which makes it in some respects the more vital and youthful of the two. So size is not the whole story. A galaxy with more stars is not necessarily the more alive of two. There is a lesson there, gentle and worth carrying, that abundance and vitality are not always the same thing. At the heart of each galaxy lies something extraordinary, and here the two differ sharply. Both Andromeda and the Milky Way harbor a supermassive black hole at their very center, but the two are not at all the same size. The black hole at the heart of our Milky Way holds the mass of roughly 4 million suns, gathered into a region from which not even light can escape. The black hole at the center of Andromeda is far greater still, estimated at something like 100 million solar masses, more than 20 times the weight of our own. That immense difference gives Andromeda a more dominant gravitational anchor at its core, a heavier center around which its inner stars wheel. And yet, despite its size, Andromeda's central black hole is relatively quiet, not currently consuming matter at any great rate. Sitting in a kind of dormant calm, rather than blazing with the violence of the most active galaxies. We will return to that strange dark heart later in the night, for it deserves its own slow consideration. The very shapes of their spiral arms differ as well. Our Milky Way's arms are somewhat loosely wound, giving our galaxy a relatively open and airy structure. Andromeda's arms are broader and threaded with more lanes of dust, making them appear more dramatic, more sculptural in long photographs. These differences in form may be the lingering record of past encounters, for both galaxies carry histories of having merged with and absorbed smaller companions. Our Milky Way shows evidence of having swallowed several dwarf galaxies across its long life. Andromeda, too, bears the scars of such meals, its outer halo threaded with faint streams of stars that once belonged to smaller galaxies. Torn apart and stretched out across space by Andromeda's gravity. These past events shaped not only how each galaxy looks today, but where each is headed tomorrow. When we set Andromeda and the Milky Way beside one another, it is tempting to frame them as rivals, as though one must be declared the greater. But that is the wrong way to hold them. They are not rivals. They are partners, bound in a slow gravitational relationship that will, in the fullness of time, draw them together into a single galaxy. Their masses tug at one another across the gulf. Their companions orbit in response to their combined pull. Their futures are entwined. So while Andromeda may be the larger and the Milky Way perhaps the more actively star-forming, their true significance lies not in any contest between them but in their relationship. In the way their similarities and their differences are slowly drawing them toward a shared destiny. There is also a profound difference simply in how we see them. We perceive the Milky Way as a band of soft light arching across the night sky, thickened where we are looking through the crowded plane of its disk. Because we live inside it and cannot step outside to view its true shape, we must infer that shape indirectly from the motions of stars, from radio surveys of its hydrogen gas, from painstakingly mapping the positions of everything we can reach. We are like someone standing inside a great cathedral in the dark, learning its architecture only by touch and echo, never able to step back and see the whole. Andromeda, by contrast, we see from the outside, tilted at an angle that lets us take in its structure as a single coherent whole. And this is one of the deepest gifts our neighbor gives us. By studying Andromeda, we learn not only about Andromeda. We learn what our own galaxy must look like from far away, what we ourselves would appear to be to some distant observer gazing back at us across the dark. Andromeda is in this sense a mirror, showing us the face of our own home that we can never directly see. Let us turn now to the shape of Andromeda itself, to the great spiral arms that give it both its beauty and much of its size. When most of us imagine a galaxy, the picture that rises to mind is exactly this: the elegant sweep of arms curling outward from a glowing core. Stars and dust arranged in graceful arcs like something painted by a patient hand. This is not merely an artist's fancy. Spiral structure is one of the defining features of galaxies like Andromeda, and those arms are not only lovely to look upon, they are deeply informative. They tell us how stars are born, how matter moves through the galaxy, how the whole vast system keeps its balance across spans of time we can barely conceive. To consider the shape of Andromeda is to move from the abstraction of size into the living detail of structure, into the patterns that give this immense thing its particular character. When you look at a long photograph of Andromeda taken through a great telescope, the first thing that draws the eye is the bright central bulge, the densely packed core of the galaxy. A glowing sphere of older stars shining with a warm yellowish light. From that bulge the arms spiral outward, broad and sweeping, not as thin, delicate lines, but as thick regions crowded with stars and gas and dust. In images that capture color, the arms appear mottled and textured, patched with blue where young, hot, massive stars are burning fiercely, and streaked with dark where lanes of dust absorb and hide the light behind them. These contrasts, the bright against the dark, give the arms a kind of roughness, a visible record of all the restless processes unfolding within them. It surprises many people to learn that the spiral arms are not solid structures at all. They are not fixed rivers of particular stars, circling forever in formation. They are patterns, regions where the density of stars and gas runs higher, and the stars themselves drift in and out of these dense regions as they orbit the galactic center. Think of the arms not as walls of stars, but as something more like the slow, patient gatherings of traffic on a great highway, places where things bunch up and crowd together while the individual stars, keep moving steadily through. A star enters an arm, lingers a while in the crowding, and eventually passes out the other side, while the arm itself, the pattern of crowding, persists. This idea, that the arms are waves of density moving through the disk rather than permanent assemblies of stars, helps explain how spiral arms can endure for billions of years without simply winding themselves up tight from the galaxy's turning. The arms are not made of the same stars forever. They are regions where stars gather, like the slow swell of a wave moving across deep water, the shape traveling on while the water itself stays. Within Andromeda's spiral arms, new stars are constantly being born. Great clouds of gas, drifting cold and dark, are squeezed and compressed, and where they grow dense enough they collapse inward under their own gravity, kindling the fierce fire of fusion at their hearts and lighting up as clusters of brilliant young stars. These youngest stars often shine blue, for they are hot and massive and burn through their fuel with reckless speed. They do not live long, only a few million years, a mere breath in the life of a galaxy, but while they burn they mark the arms clearly with their light. Alongside them, in those same star-forming regions, glow soft clouds of pink and red, where the ultraviolet light streaming from the young stars excites the surrounding hydrogen gas and sets it gently aglow. These glowing clouds are nurseries, the cradles where the galaxy renews itself, bringing forth new generations of stars to replace the old. And the dark dust lanes that thread through it all, which look at first like simple shadows, are in truth reservoirs of raw material, the gas and dust from which future stars and worlds will one day be made. Without that dust, the arms would be bright but barren. With it, they are alive, endlessly producing, endlessly evolving. To trace the shape of Andromeda's arms is to trace its ongoing life, its long, quiet cycle of birth and death playing out across a stage 200,000 light-years wide. The symmetry of Andromeda's spiral is striking, but never quite perfect. Its arms are not identical twins. One appears broader, another thinner, and throughout there are knots and irregularities, small distortions in the grand sweep. These asymmetries are very likely the fingerprints of past encounters. Andromeda has its small companion galaxies, and as these have passed near it, or even plunged through its disk across the ages, their gravity has tugged at the arms, pulling them out of true, stirring up fresh waves of density and star formation. Over time, these gentle gravitational collisions leave their marks, writing a history into the very shape of the spiral. So when you look at the arms of Andromeda, you are not only seeing structure. You are reading a record of everything that has happened to it, a story written in starlight and distortion across billions of years. And if our eyes could only gather more of its faint light, if Andromeda appeared to us as bright as it truly is rather than as a dim and modest blur, the sight would stop the heart. Its arms would stretch across several degrees of the sky, far wider than the full moon, a sprawling spiral hanging visibly overhead. Imagine, for a moment, standing beneath a dark sky and seeing not a tiny smudge but a great galaxy spread across the heavens, its arms arcing wide as though to gather the whole dome of the night into an embrace, its core glowing softly at the center. That is the true shape of Andromeda, the real face of it, hidden from us only by the limits of our own dim sight. The telescopes reveal it to us in their long, patient gathering of light. But the reality is always there, always present overhead, whether or not our eyes can rise to meet it. The shape of Andromeda reaches even beyond its visible arms. Surrounding the whole galaxy is a vast and faint halo of stars, diffuse and ghostly, stretching far out into the dark. Within this halo drift long streams of stars, the scattered remnants of smaller galaxies that Andromeda has consumed and torn apart over the ages. These streams arc gently around the main disk, tracing the paths of ancient encounters, faint fossil records of meals long finished. They show us that the galaxy's shape is not fixed or final. It is constantly evolving, constantly absorbing, constantly reshaping itself through the slow gravitational dance with everything around it. The bright arms are only the most visible part. The true structure of Andromeda includes all of it, from the glowing central bulge to the faintest wisps of the outer halo, layer upon layer fading into the intergalactic dark. There is something in the spiral form that connects the vast to the small, and it is worth resting on as we drift here. Spirals appear everywhere in nature, on scales separated by almost unimaginable gulfs. In the curl of a seashell held in the palm, in the slow turning of a hurricane seen from above, in the arrangement of seeds in the heart of a sunflower, and in the great arms of a galaxy 200,000 light-years across. The same patient mathematics of growth and balance and rotation seems to express itself again and again, at every scale the universe offers. In Andromeda, that ancient pattern is written impossibly large, repeated across hundreds of thousands of light-years. To notice it is to feel, however faintly, a continuity between the smallest familiar things of Earth and the grandest structures of deep space, a quiet rhyme that runs through everything, binding the seashell and the galaxy into the same long sentence. We have spoken of 1 trillion stars almost in passing, but let us slow down and dwell on what that number really means. Because the population of Andromeda is one of its most staggering and beautiful features. To stand beneath the night sky and catch that faint blur, and then to be told that within it are gathered close to 1 trillion stars, each one a sun, is almost too much for the mind to hold at once. Numbers that large simply slip out of the grasp of everyday experience. We can picture a few. We can picture a dozen, perhaps 100, perhaps with effort 1,000. But billions upon billions become pure abstraction, words we can speak but not truly feel. And yet astronomers have found ways to count what cannot be counted, to take that soft blur and turn it into a careful census of suns. The first thing to understand is that no one has ever literally counted the stars of Andromeda one by one. The galaxy is far too distant, and its stars far too numerous for any such thing. Instead, astronomers estimate, and they do it through light. Every star contributes its small portion to the total glow, and when all those portions blend together, the galaxy shines as a whole. By measuring that total brightness and comparing it carefully to models of how different kinds of stars are distributed, astronomers can estimate how many stars must be present to produce the light we see. It is a method built on averages and on careful assumptions about the mix of star types, but it gives us a number to hold, a way of putting our arms, however imperfectly, around the immensity. And those estimates point toward something close to 1 trillion stars, more than double the number thought to fill our own Milky Way. The stars of Andromeda are not all alike. They range across an extraordinary variety. There are massive blue giants that burn hot and brilliant and die young, blazing through their fuel in only a few million years before exhausting themselves. And there are cool red dwarfs, small and dim and patient, that will go on glowing faintly for tens or even hundreds of billions of years, far longer than the universe has so far existed. The red dwarfs are the quiet majority, the countless faint suns too dim to see even from nearby, forming the vast unseen backbone of the galaxy's population. A smaller fraction are stars much like our own sun, steady and yellow, burning patiently for billions of years. And scattered throughout, rarer but radiant, are the great bright giants that light up the spiral arms and give the galaxy its visible shape. Each kind plays its part in the slow life of the whole. Astronomers study these populations by spreading Andromeda's light out into its component colors, into a spectrum, much as a raindrop spreads sunlight into a rainbow. Within that spread of color lie subtle dark lines, the fingerprints of particular elements, and these fingerprints reveal the temperatures and the types of the stars producing the light. By reading them and comparing them to careful models, astronomers can estimate not only how many stars there are but what kinds, and from that, the total mass of the galaxy. And the spectrum reveals something more, something almost like memory. It tells the story of how stars have formed in Andromeda across its long history. The galaxy has not produced new stars at a steady, unchanging rate. There have been seasons of intense activity, when stars kindled rapidly across the arms, and quieter ages when the making of stars slowed almost to stillness. These long cycles are written into the populations we see today. The young blue stars mark the most recent bursts of birth. The old red stars are the lingering remnants of generations long past. The mixture of them together tells the tale of billions of years of a galaxy, endlessly renewing itself through the patient turning of birth and death. One of the most humbling things to sit with as you drift is the recognition that each of those stars may be a whole system in itself. Many stars hold planets. Many of those planets may hold moons. Each one is its own small cosmos, its own quiet arrangement of worlds turning in the dark. To say that Andromeda holds 1 trillion stars is, in a real sense, to say that it may hold trillions upon trillions of worlds. Most of those worlds, no doubt, are barren, scoured or frozen or drowned in crushing atmospheres. But even a small fraction of so vast a number would represent an abundance of places beyond any reckoning, an immensity of possibility folded into that single faint smudge of light. The numbers grow so large that they slip past comprehension, and yet they are real, grounded in the patient measurement of light we can actually gather. If you wish to feel the abundance rather than only to think it, picture the night sky here on Earth at its very best. On the darkest of nights, far from any human glow, a person with good eyes might see a few thousand stars scattered across the whole dome of the heavens. Through a small telescope, tens of thousands swim into view, and the Milky Way itself, seen from within, appears as a soft river of countless points too numerous to separate, a luminous mist of stars. Now take that whole sense of overwhelming abundance, the entire glittering bowl of the darkest sky you can imagine, and multiply it by hundreds of times over. That is Andromeda. Every faint shimmer in its disk, every soft glow in its halo, is another sun. The richest night sky we will ever stand beneath is only the tiniest fragment by comparison, a few grains against an entire shore. These stars are not merely lights, either. They are the very fabric of the galaxy, the threads from which it is woven. They orbit the galactic center in great patient streams, some wheeling in tight circles near the crowded core, others tracing wide and lonely arcs far out in the dim outskirts. Together, their combined mass and motion create the gravitational balance that holds the whole spiral together. Without them, the arms could not persist, the rotation could not hold. And folded among them are the relics of Andromeda's past, the streams of stars in its halo that once belonged to smaller galaxies, now stretched and blended into the larger whole, each one carrying its own faint history. The galaxy is not a finished thing, a static collection set down once and left alone. It is an evolving system, still growing, still gathering, still slowly incorporating others into itself, and each addition deepens its immensity a little further. Now let us turn our attention to something less obvious than the stars, something that does not shine the way they do, and yet without which the galaxy could not live. Between the stars, threaded through the arms, lie the great clouds of gas and the fine curtains of dust that fill the spaces in between. This is the interstellar medium, and it is the breath of the galaxy. Without it, a galaxy would be a static thing, its fate already sealed, its stars burning slowly down toward darkness one by one with nothing to replace them. Until at last nothing was left but cooling embers and the dark. With dust and gas, a galaxy is alive, capable of renewing itself, of bringing forth new generations of stars, of changing its very shape across the ages. In Andromeda, as in other spiral galaxies, this living medium is concentrated in the disk, woven into the spiral arms, gathered into the same regions where the new stars are born. Dust and gas may sound thin and insubstantial, almost like nothing at all, but together they make up a significant portion of the galaxy's visible substance. Great clouds of hydrogen drift across hundreds of light years, cold and dark and quiet, until something disturbs them, a passing shockwave or the gentle pull of a density wave. And they begin to collapse, gathering inward until new stars ignite at their hearts. The dust, made of tiny grains of heavier elements forged in earlier stars, scatters and absorbs the light passing through it, reddening and dimming the stars behind, painting the dark lanes that thread so dramatically through Andromeda's arms. To the eye, dust looks like an absence, a shadow, a place where the light has been taken away, but in truth it is potential. It is the raw material from which stars and planets, and perhaps one day even life, will be made. Within the densest, coldest clouds, the temperature drops low enough for atoms to join into molecules, for hydrogen to pair into the molecular clouds that become stellar nurseries. In Andromeda, vast regions of these nurseries exist, glowing faintly in the infrared light that our eyes cannot see. Dark and unremarkable in ordinary light, but revealed by special instruments as glowing, structured, intricate clouds. These are the lungs of the galaxy, the places where it breathes out new stars. The gas does more than make stars. It also reveals secrets through its motion. Astronomers have mapped the movement of hydrogen clouds throughout Andromeda using radio telescopes, which can detect a particular faint signal that neutral hydrogen gives off. A soft note sounding at a wavelength of about 21 centimeters. By tracing that signal, they can see how the gas flows and orbits and clumps and feeds the making of stars, and these radio maps reveal structures that the starlight alone never shows. Arms of gas reaching out even farther than the visible stars. And here again, the gas tells us about the unseen. The speeds at which these outer gas clouds orbit cannot be explained by the visible matter alone. They move too fast, held in their swift orbits by something we cannot see, and so the turning of the gas becomes one more quiet piece of evidence for the great dark halo cradling the galaxy. The dust, too, carries its own kind of information. By measuring how it reddens and dims the light passing through it, astronomers can map where it lies and how much of it there is. Instruments built to see in the infrared have shown that Andromeda holds vast reservoirs of dust, arranged not in a smooth, even spread, but in curious rings and arcs that trace out the galaxy's structure. These ring-like patterns may themselves be the fingerprints of an ancient encounter. A moment long ago, when a smaller galaxy passed through Andromeda's disk and sent ripples of compressed gas and dust spreading outward like the rings that spread across a still pond when a stone breaks its surface. In this way, the dust becomes a kind of memory, holding the record of collisions that happened millions of years before any human walked the Earth. Without dust and gas, the galaxies would eventually go dark. The stars would age and die, leaving behind their cooling remnants, and no new stars would rise to take their places. It is the continuous cycle, the gas collapsing into stars, the stars forging heavier elements, and at last exploding to scatter that enriched material back into space. and new stars forming again from the enriched clouds that keeps a galaxy alive across the ages. In Andromeda, this cycle has turned for billions of years. The heavy elements held in its dust grains today were forged in the cores of earlier stars, spread by their deaths, gathered again into new clouds, used again to build new suns and new worlds. Each turn of the cycle enriches the next, seeding the coming generations of stars and planets with the very materials needed for complex chemistry, and perhaps, in some quiet corner, for life itself. The atoms that might one day form a living thing in Andromeda were made in stars that died long before, and the same is true of us. The carbon in your body, the oxygen in every breath, the iron carried in your blood, all of it was forged in stars and scattered by their deaths, and gathered again into the cloud that became our sun and its planets. We are, quite literally, the cycle made aware of itself, the gas and dust grown patient enough across billions of years to look up and wonder at the galaxy that made it. To think of a galaxy as breathing is not merely a pretty figure of speech. It captures something true about the rhythm of inflows and outflows, of the slow gathering of gas into dense clouds, and the exhaling of starlight and enriched material back into the dark. The rhythm is not quick like a human breath. It unfolds across millions of years, a single slow inhalation and exhalation that no living thing could ever perceive within a lifetime. But it is a rhythm nonetheless, a deep and patient pulse of creation that has sustained Andromeda since long before the Earth existed. And one day, far in the future, the galaxy may at last exhaust its reserves of gas, settling into a quieter age in which few new stars are born. But that day lies unimaginably far ahead. For now, Andromeda is still breathing, still alive with the cycles of birth and renewal, still bringing new suns into being even as we rest here and speak of it. Let us now drift inward, past the spiral arms and the rings of dust, past the great crowds of stars, all the way to the very center of Andromeda, where something waits that cannot be seen at all, and yet shapes everything around it. At the heart of the galaxy lies a supermassive black hole, an object so dense that not even light can climb free of its grasp, holding within itself the mass of perhaps 100 million suns. It is invisible by its very nature, for it gives off no light of its own, and yet its presence is utterly undeniable, betrayed by the way everything near it moves. It is the gravitational anchor, around which the entire inner galaxy turns. When people hear the words black hole, they often picture a kind of cosmic drain, a hungry mouth pulling in everything around it. But a black hole, even one as immense as this, is not simply an emptiness that devours. It is a region where matter has been compressed to such unthinkable density that the ordinary laws of physics bend and strain. At its core lies what we call a singularity, a point where our equations break down and density seems to climb toward the infinite. Around that point lies a boundary we call the event horizon, the edge beyond which nothing, not even light, can ever return. The black hole itself is utterly dark, and yet the space around it can blaze with brilliance. For as gas and dust spiral inward toward the horizon, they are heated by friction and compression into extreme and glowing states, so that the darkest object in the universe can be ringed by some of the brightest light. In Andromeda, though, that ring is quiet. The central black hole, vast as it is not currently feeding on much material, and so it lies relatively dormant, dark and still rather than blazing. We detect this hidden heart not by seeing it, for it cannot be seen, but by watching how the stars near it move. The stars closest to Andromeda's center sweep around at extraordinary speeds, racing along paths that simply cannot be explained by the visible matter present. There must be something more there, something enormous and unseen, holding them in their swift orbits. By mapping these motions carefully, astronomers infer the presence of the supermassive black hole, invisible yet undeniable. And from the speeds of the fastest stars, they refine their estimate of its mass. It is a strange and beautiful kind of seeing this, to know an object so certainly while never once glimpsing it directly, to read its presence entirely in the motions of the things it commands. The sheer size of Andromeda's black hole raises a quiet question. How did it come to be so large? Did it begin small, born from the collapse of a single massive early star, and then grow slowly across billions of years by drawing in surrounding material a little at a time? Or did it grow swiftly in the young universe, perhaps through the mergers of several smaller black holes joining into one? Its great mass suggests a long and complicated history, very likely involving both patient growth and violent mergers. And because Andromeda itself has absorbed smaller galaxies over the ages, the central black holes of those smaller galaxies may well have spiraled inward and merged into Andromeda's own. Each union adding to its mass, each one a slow and silent cataclysm at the galaxy's heart, releasing tremendous energy and reshaping the core. The black hole's size, in other words, may be a kind of accumulated history, the gathered weight of everything Andromeda has ever consumed. What makes this dark heart so striking is not only its mass but its role. It is not merely an object that happens to sit within the galaxy. It is woven into the galaxy's very identity. The motions of the stars in the central bulge, the flow of gas inward, even the shape of the inner regions, all are shaped by this hidden anchor. Without it, the inner galaxy would not move as it does. In that sense, the black hole is as much a part of Andromeda's immensity as its spiral arms or its halo of stars. It is the unseen center, the silent weight around which all the visible splendor quietly turns. To imagine the environment near such a black hole is to step into a place of extremes that strain even the imagination. Gravity there is fierce enough to bend the very paths of light, fierce enough to stretch and slow the passage of time itself. Gas falling inward is heated to millions of degrees, glowing in the high-energy light of X-rays. Magnetic fields twist and snap. The fabric of space curves visibly. If somehow you could orbit close to such a place without crossing the fatal horizon, time itself would run more slowly for you than for the rest of the universe. So that you might linger there a while and return to find the galaxy aged far beyond your reckoning. The stars wheeled on, ages passed, while for you only moments had gone by. This is not the stuff of fantasy. It is the plain consequence of the way gravity bends space and time, a truth woven into the deepest laws we know. And all of it unfolds, invisible to our eyes, at the center of that faint and gentle blur you might catch on a clear night. When at last Andromeda and the Milky Way come together, billions of years from now, their two central black holes will not escape the meeting. Slowly, across long ages, they will spiral toward one another, losing energy through the gentle drag of gravitational interaction, drawing closer and closer until at last they merge into a single, even greater black hole, weighing hundreds of millions of suns. That final union will send out gravitational waves, ripples in the very fabric of space and time, spreading outward across the cosmos at the speed of light. We will not be here to feel them pass. But the prediction is clear and certain. The silent dark hearts of our two galaxies are not merely passive anchors. They are participants in a slow cosmic event that will unfold across spans of time beyond all human comprehension, an event already, in the gentlest sense, set in motion. We have touched on Andromeda's companions, but they deserve a slower visit, for to understand how large the galaxy truly is, we must consider not only its glowing disk, but the whole family of smaller galaxies that orbit it. Just as our Milky Way keeps its own companions, those soft, cloudy patches visible from the southern hemisphere, Andromeda is surrounded by a retinue of lesser galaxies. faint and far less imposing than their giant neighbor, yet bound to it by gravity, circling it across millions of years. Together they form a system, a household of galaxies with Andromeda enthroned at the center. The galaxy's true reach is not only the span of its visible arms. It is the whole gravitational domain in which it holds sway, a sprawling region that encompasses dozens of smaller worlds of stars. The two most prominent of Andromeda's companions are a pair of compact elliptical galaxies that sit close beside the Great Spiral, visible even in modest telescopes as faint patches near the edge of the disk. One is small and unusually dense, its stars packed tightly together so that it shines brighter than its size would suggest. It may once have been a larger galaxy, gradually stripped down by Andromeda's gravity until only its concentrated core remained, a galaxy worn away to its very heart. The other is more diffuse, a fainter and softer glow, trailing faint streams of stars that hint at how it too has been shaped and pulled by its long association with its giant neighbor. These two have orbited Andromeda for ages, attendants close beside the larger figure. Beyond these two, Andromeda hosts dozens of dwarf galaxies, many so faint that they were discovered only in recent decades. Revealed by careful surveys that picked out subtle gatherings of stars against the background dark. Some of these dwarfs are irregular and shapeless, looking more like scattered handfuls of stars than structured galaxies. Others are smooth and spheroidal, faint and featureless, little more than soft shadows in the dark. Each holds perhaps a few million or a few tens of millions of stars, tiny against Andromeda's trillion, yet still enormous beyond anything we can directly experience. A single one of these dwarf galaxies, set beside our solar system, would dwarf every structure we know. And yet against Andromeda it is a whisper, a fragment of light circling in the giant's long shadow. The relationship between Andromeda and its companions is never still. Gravity is always at work among them, pulling, stretching, distorting. Some of the smaller galaxies are even now being slowly torn apart, their stars drawn out into long streams that wrap around Andromeda like ribbons caught in a slow current. These streams are visible in deep images as delicate arcs of scattered stars, the traces of past encounters, the evidence that Andromeda has grown across the ages by consuming its smaller neighbors, tearing them apart and weaving their stars into its own halo. This process has not ended. Even now, some of Andromeda's companions are being slowly digested, their structures stretched and dissolved into the greater whole. It is not a violent thing to witness, for it unfolds across millions of years, but it is relentless. The giant grows by gathering the small. This same behavior plays out around our own Milky Way, which is in the slow process of consuming one of its own dwarf companions, pulling it apart into streams that wrap around us. But because Andromeda is larger, its reach is longer and its influence stronger, and the number of companions it has absorbed across its long life may be greater still. The streams and shells of stars that surround it are a kind of fossil record, the remains of galactic meals written across the dark in faint arcs of starlight. To study them is to read Andromeda's history, to see not only what it is now, but everything that has gone into making it so. These companions matter for more than their beauty and their slow consumption. They tell us about the nature of the cosmos itself, about the unseen dark matter that shapes everything. According to our best understanding of how galaxies form, every large galaxy should be surrounded by a host of smaller ones, each cradled in its own halo of dark matter. The fact that Andromeda and the Milky Way each keep dozens of known companions fits this picture, lending quiet support to our theories of how the universe is built. Each new faint companion discovered adds another small confirmation, another piece in a puzzle that stretches from the smallest dwarf galaxy to the largest structures of the cosmos. And there is diversity in these companions worth resting on. Some are rich in gas, still forming new stars, still alive with creation. Others are gas-poor and quiet, holding only old stars, their star-forming days long behind them. Whether a companion remains alive or fades into quiet often depends on how close it ventures to Andromeda. Those that pass near the giant tend to have their gas stripped away by gravitational tides and by the pressure of moving through Andromeda's vast halo. And without gas, the making of stars ceases, and the galaxy settles into a faint shell of aging suns. So Andromeda is not only a passive neighbor to its companions. It actively shapes their fates, deciding which will live on as active galaxies and which will fade into quiet relics, an immense and impersonal hand sculpting the small worlds that circle it. Now let us turn back through time, away from the galaxy itself and toward the long human story of noticing it. For the tale of Andromeda is not only a tale of astrophysics. It is a tale of human curiosity, of how generation after generation of watchers tried to make sense of what they saw, long before any of the tools of modern science arrived to help them. Long before telescopes, long before anyone had even the idea of a galaxy, people looked up and saw that faint blur in the dark, and though they could not know what it was, many of them recorded it, named it, gave it a place in their maps of the heavens. The understanding came slowly, across more than 1,000 years, and the patient watching of those early observers laid the ground for everything we now know. The earliest written record we can point to with confidence comes from a Persian astronomer who lived in the 10th century, a careful and devoted observer who compiled a great catalogue of the stars. In a book completed in the year 964, he described a small cloud in the constellation of Andromeda, noting its faint presence and its position among the surrounding stars. He called it a little cloud, this soft uncertainty in the dark. He was almost certainly not the first human being to see it, for people must have noticed the blur for thousands of years before him. But his is the first surviving account that has reached us across the centuries, preserved in careful ink, passed down through copies and translations. A thread of attention reaching back more than 1,000 years to a watcher gazing up at the same faint glow you might catch tonight. It is very likely that older peoples knew of it too, even if their records have not survived. The ancient Greeks mapped the constellation of Andromeda itself, tying it to their old story of a princess bound to a rock at the edge of the sea. The figure whose chain of stars stretches across that part of the sky. The faint blur we now know as the galaxy lies within that pattern, and though no surviving Greek text mentions it directly, it is hard to believe that careful watchers under the dark skies of the ancient world never once noticed it. And across the whole earth, in every culture that ever watched the heavens, there were surely eyes that fell upon that soft patch and minds that wondered at it. Many of those wonderings are lost to us now, never written down, or written on materials that did not survive the long erosion of time. But the noticing was surely there, woven quietly into countless cosmologies and stories that have faded beyond recovery. By the Middle Ages, the little cloud had entered the astronomy of Europe through the translation of Arabic texts, and it took its place on the celestial maps used by scholars. To them, it was still simply a nebula, a word used for any faint, cloud-like smudge in the sky, carrying none of the meaning that word holds for us today. It was just a description, a soft patch among the stars, catalogued but entirely unexplained. And so it remained for centuries, a known thing whose nature was a complete mystery. Then, in the early 17th century, came the telescope, and the sky changed forever. With lenses and mirrors, faint things could be magnified and brought into sharper view. A German astronomer turned one of these early instruments toward the Andromeda blur and described it as a faint, cloud-like light, larger and more distinct than the naked eye could perceive. He is often credited with the first telescopic description, though it is possible others glimpsed it around the same time. And yet, even with the telescope, the true nature of the thing remained hidden. It was still taken for a nebula, a cloud somewhere within our own galaxy, for the idea that it might be a separate galaxy of its own had not yet been dreamed. Over the following centuries, the blur was carefully catalogued again and again. A French astronomer compiling a list of fuzzy objects so that comet hunters would not mistake them for comets, gave it the designation by which it is still often known today, a number in his famous catalog. The astronomer who discovered the planet Uranus studied it too, describing its bright core and its extended faint regions. Some watchers began to speculate that these nebulae might be distant systems of stars, whole island universes lying far beyond our own. But the idea was controversial, even radical. The prevailing view held that our Milky Way was the entire universe, and that the nebulae, Andromeda among them, were simply parts of it, clouds within our single great galaxy. This question came to a head in the early 20th century in a famous public debate. On one side stood those who argued that the spiral nebulae were island universes, separate galaxies far beyond the Milky Way. On the other stood those who insisted that the Milky Way encompassed everything, that there was nothing beyond it. The nature of Andromeda lay at the very heart of the dispute. Was it a part of our galaxy, or was it a galaxy entirely its own? The debate could not be settled by argument alone. It needed a measurement, a fact drawn from the sky itself. That fact arrived a few years later, through the patient work of an astronomer using one of the great telescopes of the age, perched on a mountaintop beneath clear and steady skies. By studying Andromeda carefully, he identified within it those pulsing Cepheid variable stars, the standard candles whose true brightness could be known from the rhythm of their pulsing. He measured their periods, calculated their true luminosities, compared them to how faint they appeared, and from this worked out their distance. And the distance was vast, far too great for the stars to lie within our own galaxy. Andromeda was not a cloud within the Milky Way. It was a separate galaxy, lying millions of light years away. With that single measurement, the universe expanded in an instant. The Milky Way was no longer the whole of creation. It was merely one galaxy among countless others, and Andromeda was revealed at last as our nearest great neighbor, an island universe of its own, immense and separate and real. It is remarkable, looking back, to consider how long humanity lived with Andromeda as nothing more than a faint blur, a little cloud noted in passing in old catalogs. For 1,000 years after that Persian astronomer first wrote of it, it remained an unsolved mystery. Only in the last century did we finally learn its true nature. The galaxy itself, of course, did not change across all that time. What changed was us, our tools, our concepts, our willingness to question the assumptions we had inherited. And the very names by which we have called it trace that growing understanding, like rings in the trunk of a long-lived tree. First, it was a little cloud. Then it was the Andromeda Nebula. Then a number in a careful catalog. And finally, at last, the Andromeda Galaxy. Each name marks a stage in the long story of human comprehension. Even now, when we speak of it simply as Andromeda, we carry all those layers of history quietly within the word. And there is something deeply moving in the fact that people noticed it at all. It is faint, easy to miss, demanding patience and dark skies and a willingness to look slightly to the side. And yet, generation after generation, watchers saw it and wondered, and gave it a place in their maps and their myths and their catalogs, and preserved it, passing it carefully down through the centuries so that, when at last the tools arrived to reveal its true nature, the object was already known, already marked in the sky, already waiting. Without that long, unbroken chain of attention, the astronomer with his great telescope might not have known where to look or what questions to ask. The faint blur in the constellation of a chained princess became, in the end, the key that unlocked the true immensity of the universe. And every watcher in that long chain, from the ancient stargazers to the medieval scholars to the modern astronomers, was simply doing what you might do tonight, in your own quiet way, by letting your attention rest on that soft and ancient glow. Noticing, wondering, continuing the lineage. From that single faint blur, our instruments have gone on to draw out a galaxy alive with extraordinary detail, and it is worth resting on what the great telescopes of our own age have shown us. When the first powerful telescope was turned on Andromeda and individual stars could be picked out within it for the very first time, that was the breakthrough that proved it lay beyond our galaxy. But in the years since, the tools have grown beyond anything those early observers could have imagined. A great telescope lifted above the atmosphere into the clear dark of space has captured images of Andromeda of such fineness that its cameras resolved millions of individual stars within the galaxy, something no telescope on the ground could ever match through the shimmering blur of our own air. One enormous mosaic assembled from such observations stunned the world when it appeared, a panorama of more than 1 billion points of light, each tiny point a star, filling the spiral arms in such fine detail that the eye could wander through it almost endlessly, lost among the suns. That image remains among the largest astronomical photographs ever made, and it gave us, for the first time, a true human sense of the galaxy's immensity, not as a number on a page, but as a sea of stars stretching beyond the edge of comprehension. But the visible light that our eyes can perceive is only one narrow band of a much wider spectrum. And telescopes built to see in other kinds of light have opened windows onto aspects of Andromeda entirely invisible to the unaided eye. In infrared light, instruments have shown the galaxy's dust glowing warmly, tracing out those curious rings and arcs that betray its history of ancient encounters. Structures wholly invisible in ordinary light, but shining clearly in the warmth of the infrared. In ultraviolet light, telescopes have revealed Andromeda's population of hot young stars, lighting up the regions where new clusters are even now being born, highlighting exactly where the galaxy is most actively renewing itself. The contrast between these two views is striking and beautiful. One shows the raw material, the cold dust waiting to become stars. The other shows the result, the brilliant young suns just kindled. Together they tell the story of the galaxy's endless cycle of creation, the slow turning of dust into starlight and back again. In the high-energy light of X-rays, other telescopes have observed the violent processes hidden within Andromeda, the glowing remnants of exploded stars, vast shells of gas expanding into the dark, and the faint activity around the central black hole itself. And in the long wavelengths of radio light, telescopes tuned to that soft signal of neutral hydrogen have mapped the gas of Andromeda, revealing how it extends far beyond the visible disk, stretching the galaxy's true size and showing how the gas flows and turns within it. Each kind of light reveals a different layer, a different aspect of the same vast object, and when astronomers overlay all these views, the optical and the infrared and the ultraviolet and the X-ray and the radio, Andromeda transforms before them into a single multi-layered portrait, not of a static thing but of a living galaxy, full of cycles and motions and quiet drama unfolding across the ages. Even the telescopes that remain on the ground have grown remarkably capable, learning to correct in real time for the blurring shimmer of our atmosphere, achieving a clarity once thought possible only from space. From mountaintops beneath the clearest skies on Earth, they have captured exquisite images of Andromeda, resolving its star clusters, tracing its dust lanes, measuring the slow motions of its stars. Wide surveys have mapped its faint halo and detected the streams of stars torn from its consumed companions. And among the most striking discoveries of all is the realization that Andromeda's halo, the vast diffuse cloud of stars and dark matter that surrounds it, reaches far further than anyone once believed, stretching across so great a distance that it may already be brushing against the outer halo of our own Milky Way. If that is so, then our two galaxies, separated by 2.5 million light-years of seemingly empty space, are in the faintest sense already touching. Their outermost reaches already beginning to mingle, long before their bright disks will ever meet. The collision in a quiet way may have already begun, and yet for all this progress, Andromeda keeps some of its mysteries. Even the finest telescopes cannot reveal every detail, and the galaxy remains partly beyond our reach, partly unknown. New instruments promise ever deeper insight, the ability to peer into its star-forming regions, to study its oldest stars, to trace its long history with a clarity never before possible. Each new telescope adds another layer, sharpens the picture a little more, but the galaxy itself always retains something held back, something more to discover. It is humbling to consider how far we have come, from the days when Andromeda was simply a little cloud noted in an old book, to now, when we can map its arms and count its stars and weigh its hidden black hole. And still the blur remains. To the naked eye, Andromeda appears exactly as it always has, a faint soft patch in the dark. All our instruments have transformed our understanding utterly, and yet they have not changed the simple experience of standing beneath a dark sky and seeing it with our own eyes. That experience remains as ancient as it is modern, as full of mystery as it is full of knowledge. Now let us turn, at last, toward the future, toward the slow and certain meeting that lies ahead. For Andromeda, as we have said, is not standing still. Despite the vast gulf that separates us, despite the 2.5 million light-years of seemingly empty space, the galaxy is moving toward us, drifting steadily nearer. Drawn across the dark by the patient pull of gravity. The measurements are clear, written in the blue shift of its light. It is coming, at something like 110 kilometers each second, and though that sounds swift, across so vast a distance it is the gentlest of drifts. The meeting will not come tomorrow, nor in 1,000 human lifetimes, nor in 1,000,000. It lies some 4 billion years ahead. But it is coming, and it is certain, and there is a strange and quiet beauty in being able to see so far into the future of the heavens. To picture what such a meeting means, we must first set aside a misunderstanding, gently. Galaxies are not solid things. They are mostly empty space, with their stars separated by gulfs so vast that even when two galaxies pass through one another, the chance of any two stars actually colliding is almost nothing. The stars simply slip past each other across the enormous distances between them, like two great clouds of midges drifting through one another on a summer evening, each insect passing untouched through the gaps. What happens instead is subtler and grander. The gravity of the two galaxies grips and stretches and reshapes them, drawing out long tidal tails of stars, flinging suns onto new orbits, while the great clouds of gas, which fill much more of the space than the stars do, crash and compress against one another, igniting brilliant new waves of star formation. Over billions of years, the two spirals will fall together, draw apart and fall together again, spiraling slowly inward until at last they merge into a single new galaxy, blending their stars and their dark matter into one. Astronomers have modeled this future in great detail, letting powerful computers play forward the slow dance of gravity. In these visions, Andromeda and the Milky Way approach one another gradually, their halos overlapping first, then their disks beginning to interact. On the sky of any world that survives to witness it, Andromeda would grow larger and larger across the ages, no longer a faint blur but a vast and dominant presence spreading across the heavens. When the galaxies first passed through one another, great arcs of stars would be flung outward into the dark, tidal tails stretching across space. Then, drawn back by gravity, they would fall together again, their motions spiraling ever inward, until at last they coalesced into a single galaxy. And that final galaxy would not be a graceful spiral like either of its parents. It would be a giant elliptical, a great smooth rounded gathering of stars, having lost the delicate arms that once defined the two. A new galaxy, born from the union of our own and our nearest neighbor, sometimes given a name that blends the two together. For any world like the Earth, the collision would be at once dramatic and strangely gentle. Dramatic, because the night sky would change beyond all recognition. The familiar band of the Milky Way would be joined, over the long ages, by streams and arcs of stars drawn from Andromeda, the heavens growing ever more crowded and intricate, filled with patterns no eye has ever seen. Gentle, because the vast distances between the stars mean that any particular solar system, our own included, would very likely pass through the whole upheaval untouched. Simply carried into a new orbit within the merged galaxy, its planets still circling their sun as they always had, only the sky around them transformed. The true violence would be felt in the gas, where colliding clouds would blaze into new waves of star birth, lighting up the merger with the fierce blue brilliance of countless newborn suns and great glowing nebulae larger than anything in our sky today. To any beings alive to witness it, the heavens would be ablaze with both old light and new, a spectacle of creation unfolding across spans of time too long for any single life to follow. To contemplate this future shifts our sense of time in a way that can be quietly profound. 4 billion years feels impossibly far. All of human history is measured in mere thousands of years. Whole civilizations rise and fall across centuries. Our species itself is only a few 100,000 years old. And yet 4 billion years is roughly the span of the Earth's history so far, from its fiery formation to this very moment, to you resting here beneath your blanket. To look forward that far is to imagine spans across which continents drift and reshape themselves, oceans open and close, mountain ranges rise and wear away to nothing. Stars are born and live and die. It is less a prediction of what any human will see than a recognition of what galaxies simply do, of how the universe evolves across its immense and patient ages. By the time our two galaxies meet, our own sun will be nearing the end of its life, swelling into a red giant, and the Earth as we know it will likely no longer be a home for life. Humanity, if it endures at all, will have changed beyond recognition, or found other worlds or passed quietly into the long silence. The merging galaxies will be witnessed, if by anyone, by beings we cannot imagine, or by no one at all. The sky will rearrange itself in glory whether or not there are eyes to see. And there is, I find, a deep comfort hidden in all of this, a comfort fit for the edge of sleep. The collision is inevitable, yes, but it is also unimaginably slow, unfolding so gradually that no single moment within it would ever feel like catastrophe. Stars will go on shining throughout. Planets will go on circling. The two galaxies will dance together across billions of years, their structures blending in the gentlest slow motion. For anyone alive in the early stages, the changing sky would be a spectacle, not an ending, a slow and silent splendor playing out across more lifetimes than could ever be counted. The universe is not rushing toward any cliff. It is turning, patiently, through changes so vast and so gradual that even a collision between galaxies becomes a kind of serene and stately dance. And this, perhaps, is the gentlest lesson Andromeda has to offer as the night grows late. There is something quieting in knowing that galaxies move on time scales so long that our own worries, our own anxieties, the small urgent troubles that press upon us in the bright hours of the day, soften and shrink against such a backdrop. This does not make those troubles meaningless. Your life, your loves, the things you care for are real and they matter. But set against the slow billion-year turning of the galaxies, the things that feel so heavy in the dark of a restless night find their proper proportion. They become a single quiet note within a vast and patient symphony, a symphony that began long before us and will continue long after, and within which we are granted, for a brief and precious while, the chance to listen. For we are not separate from any of this. That is the truth worth carrying down into sleep. Andromeda is not only out there in the dark, a distant and unreachable thing. It is in here too, in the very atoms of which you are made. The carbon in your cells, the oxygen filling your lungs as you breathe slowly now, the iron carried in your blood, the calcium in your bones. All of it was forged in the hearts of stars and scattered by their deaths across the dark, gathered up again into clouds, and built at last into the world and into you. The same processes that fill Andromeda with light filled you with life. The vastness is not only outside us, it runs through us. We are the universe, grown briefly aware of itself, given the strange and lovely gift of being able to look up at a faint patch of ancient light and know it for what it is, and feel, however quietly, our kinship with it. So as the night settles fully around you, let your mind drift one last time toward that soft glow. Imagine it as it is now, turning slowly in the dark, its trillion suns wheeling around their hidden center, its arms threaded with dust and cradling newborn stars. Imagine it as it was when its light began the long journey to your eyes, 2.5 million years ago, when the world was young and our ancestors were only beginning. And imagine it as it will be, 4 billion years from now, drawing near at last, filling the sky of some future world with a slow and silent splendor. The mind cannot hold all of that at once, and it need not try. It can simply wander gently among the pieces, moving from the stars to the dust, to the great dark heart, to the slow approaching dance, and finding rest in the deep rhythm of it all. The immensity that asks nothing of you, but to be quietly wondered at. You are small, it is true. We all are, measured against such scales, but smallness is not the same as insignificance. A single flower is small beside a mountain, and yet it is no less precious for that. A single thought is weightless beside a planet, and yet thought is the rarest and strangest thing the universe has so far managed to produce. You are brief, yes. Your life is a thin, bright line, drawn across a canvas of unthinkable vastness. But it is your line, and you are drawing it, and the very fact that you can lie here at the edge of sleep and hold a galaxy in your mind is itself a kind of quiet miracle. A meeting of the human scale and the cosmic scale that the universe arranged across billions of years, so that this single moment, your moment, could happen at all. The galaxy will continue long after you close your eyes tonight, long after you wake to whatever the morning brings, long after all of us are gone and forgotten, and our world itself has changed beyond all knowing. Its stars will rise and fall, its arms will turn and shift, its slow meeting with our own galaxy will unfold in its own distant time, but tonight, in this quiet moment, its light has reached you. Photons that left their stars 2.5 million years ago have ended their long journey here, in your awareness, in your gentle wondering, and that is enough. You have done your small part in the long human story simply by noticing, by letting that ancient glow rest a while in your mind as you let your body rest. So let your breathing slow now, and let the words begin to blur and soften as a galaxy softens into a smudge of light. Let go of the distances and the numbers and the names. Keep only the feeling, the soft sense of something immense and patient and beautiful turning slowly in the dark, far away and yet somehow near, ancient and yet arriving fresh in this very moment. Let it become a companion in the night, a quiet glow at the edge of your awareness, reminding you that even in the deepest dark there is always more beyond, always something greater and gentler, and more wonderful than the small troubles of any single day. There is always a reason to look up, even if only in memory, even if only in the soft drift toward dreams. Rest now. The light has traveled so very far to reach you, and it asks nothing in return. Let it carry you gently down into sleep. May your night be deep and untroubled. May your thoughts grow soft and quiet, and may you drift easily into dreams, held all the while beneath the faint and faithful glow of a trillion distant suns. Thank you for spending this quiet time beneath the stars. Whenever you wish to return, the sky will be waiting, and so will I. For now, simply rest, and let the universe keep you company through the night.